All right, scale is not as complicated as you probably think it is. It's pretty straightforward. It takes a little time to wrap your head around it, but as soon as you wrap your head around it, the light bulb will go off, and I think you will get it quite easily.
Get the actual set, when we get the piece, it'll follow exactly these specifications. I mean, even these contours and everything.
I don't understand you.
But I mean,
get the actual piece.
Well, when you build the actual piece.
But this is what you asked for, isn't it?
What?
Well, this is the piece.
This is the piece?
Yes.
Are you telling me that this is it? This is scenery? Have you ever been to Stonehenge?
No,
The triptychs are 20 feet high. You can stand 4 men up them.
Ian, I was asked
This is
to build
insane.
a triptych
This isn't a
18
piece of
inches
scenery.
high. Look, this is what I was asked to build. 18 inches, right here. It's specified 18 inches. I was given this napkin.
Forget this. Fuck the napkin.
If you haven't seen This Is Spinal Tap, you need to see This Is Spinal Tap. It's a very, very funny movie with a whole lot of people in it that you will recognize. And I just love that scene because it's all about difficulties with scale. We've been using scale our whole life, right? All the toys that we had as kids are in some kind of scale. So if you play with G.I. Joes or Barbies or whatever, you've got some kind of scale. Star Wars action figures are pretty close. They're a little bit bigger, but pretty close to the half-inch scale that we use frequently in theater. All scale is just a substitution. If you've been on vacation somewhere where the currency was not dollars, if you've been to Europe and you had to think of things in euros or Mexico in pesos or whatever, if you go someplace where you've got to do that substitution about money, well, you've done kind of the same thing. And a full scale model of our set would be the same size as the set. That would be a 1-to-1 ratio. So if we had something that was worth $1, for example, we could just change the word out, right? We do that all the time now with bucks, right? If somebody says to you, how much is that? And somebody says, oh, that's $6. You don't go, bucks? What do you mean? I don't have any male deer, right? No, of course you make the substitution in your head that buck means dollar, right? So we do that already. So if we said a clam is equal to $1, our currency suddenly becomes clams. And I say that's going to cost you six clams, and a clam is worth $1. You know that was $6. That's pretty straightforward. But maybe a clam is worth more than $1, and we decide that a clam is worth $5. Just like a euro is not quite worth $1, you got to do some math there. But if it'll cost you 6 clams, and each clam costs you $5, then 6 times 5 is 30. Now you're spending a lot more than $6 because you're now spending a lot more dollars per clam. That's really all that scale is, except we're dealing with dimensions instead of money. So that scale ratio we've talked about, that 1-to-1 scale, that's full scale. So the 1-to-1 scale model of the set is the set because it's full size, right? So the only reason why we choose to put things in smaller scales is to make them more manageable. I've got to fit it on a piece of paper. I've got to build a model that I can carry around and show people. So we will frequently work in 1/4 inch or in 1/2 inch in theater. But if you've ever played with trains as a kid, right, those are in scale as well. And the kind of rare ON30 scale is in 1-to-48 ratio, which is the same thing as 1/4 inch, right? There are 4 1/4 inches in an inch, and there are 12 inches in a foot, so 4 times 12 is 48. So you can see where that number comes from. You don't have to worry about that, just know that that's what that means. And 1-to-24 is 1/2 inch scale because there are 2 1/2 inches in a foot, and you do 2 times 12, you get 24. So that's basically what that ratio comes from. So if we look over here at the G scale, that's about a 1/2 inch scale. That's basically saying there are for every 1 foot of the model, there are 22 inches. Excuse me, it's the other way around. For every 1 inch of the model, there are 22 feet in the real world. So it's not quite the 24 that we would have in 1/4 inch, but it's pretty close to that. So if a train car in that gauge, that G scale gauge, was a foot long, if I pulled out a tape measure and I measured it, it's a foot long, the little toy train, then we can say, well, that's representing a train car that is 22 feet, because 1-to-22 means that 1 foot of our tape measure measurement is going to be the same thing as 22 feet in the real world. So if I measured something with my tape measure that was 6 inches long, half of a foot, we could say that's 11 feet in the real world, in the actual train car. We can do that exact same thing with maps too. If you wanted to figure out how far it is roughly between Beijing and Shanghai, you could look down at the scale bar there on the map and go, okay, well, a line that long is 800 miles. And that turns out to be almost exactly how long that distance is between Beijing and Shanghai. Now, if we actually drove the roads, it's going to be longer than 800 miles, but and maybe even if we zoomed in a little bit, if we had Google Maps instead of this little snapshot here, we could zoom in and get a better measurement. If we had a bigger map, we could get a higher resolution. But we're dealing with a pretty small scale here. So if you look down there in the 1 inch equals 1 mile, that's the same thing as 1 to 62,500. So now we're dealing with a very reduced image, because a full-size map of China would be as big as China. So we have to make things smaller. Let's just do a quick fraction review. This is like 5th grade math, or I don't know, 3rd grade math, whatever. So in 1 inch, you've got 0 to 1 inch, right? That's 1 inch. Half of that, of course, is a ½ inch, and then you can divide it into quarters, like 4 quarters and a dollar. There's a quarter, there's 2 quarters, and 2 quarters gets reduced down to ½ inch. There's 3 quarters and 4 fourths, 4 quarters, and that gets reduced down to 1 whole, right? So the denominator in this here is going to tell you what the multiplier is, right? There are 4 quarters in an inch. If we drop down to 1/8 inch, there are 8 eighths of an inch, right? So there's 1/8, 2/8, 3/8, 4/8, and so on until we get to 8 eighths. And 8 eighths is the same as 1 inch. So that denominator number there is going to always help you out in terms of what the scaling factor is, right? You can reduce it further down to 1/16 of an inch, and even 32nds of an inch, and 64ths, and whatever. You can go down and down. But usually we're dealing with, this is about as precise as we can get, like in the scene shop. We might get a little preciser than that if we're dealing with something that we're maybe 3D printing or whatever. But for the most case, we're really only having to deal with these big ones here, the 1/4 inches and the ½ inches. So let's go ahead and jump into there. Also remember that quote marks are inches and apostrophes are feet. So the scene from Spinal Tap there is the idea that she was handed this napkin that had 18 inches, and she made 18 inches instead of 18 feet, which is what they thought they were asking for. So that's the joke that's happening in that scene. So 2 foot 6 inches is 2'6 quotes, just to be clear on that. Most of the measuring that you can do here, you can do with a regular ruler. The only reason why we have that fancy scale ruler is just to make it go faster, so we're not having to do the math in our heads. Let's start with the easiest scale, which is 1 foot. Is the same as 1 inch. So 1 inch equals 1 foot 0 inches. That's just the 1 clam equals $1. It's pretty easy to do. So a 1 inch line on our piece of paper that's being drawn in scale, if I drew a 1 inch long line and I was drawing in 1 inch equals 1 foot scale, how long would that line be? It's not a trick question. It really is that simple. It's 1 foot. 1 inch equals 1 foot. I just drew an inch. That's a foot. That's kind of all there is to it. If I were to draw a 2 inch long line on my piece of paper that was in 1 inch to the foot scale, how long would 2 inches be? Again, it's just 2 feet long. It's not that complicated. The only reason why we don't use that scale, like if that scale's so easy to do, why don't we do that more often? Well, it's really big. So if you ever see if you get to England and see the Harry Potter displays in the film studios, which is a really amazing place to go, the scale of the Hogwarts model is in 1 inch to 1 foot scale, and you can see how big it is. I mean, it's just massive. The whole set, the whole model, it fills like a room about the size of a basketball court. It's pretty big. The same thing with a lot of train scales. Those larger train scales are so big they have to be outside. So those scales can just be pretty cumbersome. So we use smaller scales that we can actually carry around. If you've seen my ½ inch scale models, they're really big. They're like 4 by 4. They're pretty huge. And if I were to do that in 1 inch scale, would be 16 feet. I mean, the model would be massive. I'd have to have it, on a dolly to drag around the space. So that's why we use smaller scales. So we'll use ½ inch scale a lot. So let's take a look at ½ inch. If I drew a line that was ½ inch long and I was using ½ inch scale, 1/2 inch equals a foot, how long would that line be? Again, not a trick question. It's 1 foot long. 1/2 of an inch equals 1 foot. I draw a line that's ½ an inch. It equals a foot. So pretty easy. If I drew a 1 inch long line, how many ½ inches are packed into that 1 inch? 2, right? So you got 1 and 2. That means that line is going to be 2 feet long in scale, right? It's pretty straightforward. Hopefully that's starting to make sense for you. If I drew a line that was 4 inches long, and again, I'm still in that ½ inch scale. So every inch on the piece of paper has 2 ½ inches in it, right? So you can kind of do the math there. You can just double it. Or you can go along and count. If you went along and did the counting there, 1, 2, 3, 4, 5, 6, 7, 8. Or you could just do 4 times 2 is 8, right? Because ½ inch, the denominator is 2, just double it, right? Knowing there are 2 ½ inches in every inch, that way you can say, all right, if I drew a line that's 5 inches long, twice 5 is 10 feet. If I drew a line that's 12 inches long, twice that is 24 feet, right? So that one's fairly straightforward. But we often use quarter-inch scale because it's a little easier to fit on a model or on a piece of paper. So if we say 1/4 inch equals 1 foot now, then every quarter inch is going to be equal a foot. So this little quarter inch is going to be a foot long in quarter-inch scale, just as the other ones have been. So if I draw a line that's 1 inch long, how long is that going to be in our quarter-inch scale? How many feet is that going to be in our quarter-inch to the foot scale? How many quarters in an inch? How many quarters in a dollar? It's pretty straightforward. 1, 2, 3, 4, right? So if I draw a line that's 1 inch long in quarter-inch scale, I've drawn a 4-foot long wall or whatever in my drawing. So if I drew a 4-inch long line, again, back into quarter-inch scale, what do? So we doubled it for 1/2 inch, right, which made it 8. So we're going to double it again and make it 16, right? So 4 times 4 equals 16. So there's 4/4 of an inch. So there's 4 inches, so that's 16. So hopefully that's making sense. So if we do a 5-inch long line, it would be 20 because 4 times 5 is 20 and so on, right? So hopefully that's starting to make a little bit more sense. But not everything in the world rounds to a foot. So let's go back to the 1 inch to the 1 foot scale again. So we're back. We're forgetting 1/2 inch, quarter inch for a second. We're just going to go back to that 1 inch scale, right? So if we drew this line, we know that that 4 inches is 4 feet. That's pretty straightforward. We've already established that. But what if I draw a line that's 4.5 inches long? Again, I'm working in 1/2 inch scale here, or I'm sorry, I'm working in 1 inch to the foot scale here. So I've tacked on an extra 1/2 inch there. Well, how long is that going to be? So if the distance between 4 and 5 is a foot, and I've gone half of that distance, there's 12 inches in a foot. Half of 12 is 6, right? So that line is going to be 4 foot 6 inches long, 4.5 feet long. That makes that every 1/2 inch in 1 inch scale is going to end up being 6 inches long. But what if the line were 4.25 long? Right? Well, what's half of 6? 3, right? So we know it's 4 foot something, and a quarter of an inch is the same thing as a quarter of a foot in the scale here. A quarter of a foot is 3. So 3, 6, 9, 12. Those are the divisions, right? The quarter divisions of a foot. So a 4.75 inch long line would be 4 foot 9 inches long. So we'd go 1, 2, 3 to get us to the 9. So hopefully that makes sense, right? But what about 4.25 inch long line if we change the scale now to 1/2 inch? So we've got that same 4.25 inch long line, but it's now 1/2 inch. So we know this is 1 foot, 2 foot, 3 foot, 4. So we know this is 8 foot, right? Because we're doubling here, 8 foot. And this would be 9 foot. So 4.5 inches is going to be 9 foot. So 4.25 inch is going to be the same thing as 4 foot 6 inches, right? So we're going to add that extra 6 inches. That quarter inch now in 1/2 inch scale is going to be 6 inches, half of a foot, right? So this is going to be 8 foot 6 inches because it's not quite 9. It's 8 foot 6 inches. So hopefully that's making sense there. Let's go back into 1/2 inch scale again, and let's make 1/2 inch to the foot. If we were using that for projects in various classes, it says tree houses here because this is made for another class. We're making tree houses. And so 4.5 inch line would be 9 foot long in that quarter inch scale like we were just talking about. So we go along and count up here at 8, and then one more is 9, right? So a 1 3/4 of an inch line would be 3 foot 6 inches, right? So that's starting to make sense. So in 1/2 inch, we're going along and saying 1 foot, 2 foot, 3 foot. So here's our 3 foot mark, and we're going halfway again, quarter of an inch. We haven't quite hit the 4 foot mark here, the 2, so we're going 3 foot 6 inches. And if you can get to that resolution for the stuff you're doing in here, you'll be fine. So you can keep on changing that into 1/8 inches and so on, all sorts of things, but you don't really need to. So Again, gotta watch Spinal Tap. So why do we need these weird rulers? Okay, so the thing is, we've been doing a lot of math in our head, and we sometimes need to make some measurements. So more precise than rounded to 3 increments is useful when we're doing actual drafting or real work. Now, for the elements of design assignments or even assignments in the set design class, you don't need to be that precise. But I just want to explain what this ruler is doing for you in case this is of interest to you. So you have what you need to know in order to do those assignments, but let's just go a little bit further here to explain what's happening. So the ruler has that funny shape because there are a lot of different scales, and they're able to pack a whole lot. There's 2 scales going on each blade, and there's the 3 blades, so we're getting a whole lot of different measurements that we're able to do on each one of these. So we will use the 1-inch scale occasionally, like we've been doing over here, the 1-inch scale, and we can use the 1/2-inch scale. The only problem with this is in order to pack them all in there, they do go in opposite directions. So you read from left to right on the 1/2-inch and from right to left, and it's pretty easy to figure out why that is, and I'll show you that here in a second. So there are 2 scales running in different directions on each blade, just be aware of that. That's why some of these things look a little odd. But let's zoom into the little corner of that 1/4-inch scale there. So we're going to just jump in there, zoom in to that bit there, and we're going to look and see that there's a 0 right here on that scale ruler. And if we start reading from right to left, we're going to read 0 and then 10. And that first thing we hit is 10. Well, that's 10 inches, 10 feet in the other direction over here. So we can ignore this and just know that's a 1/2 inch. So this is actually 1. And then it gets back, these shorter lines here are the ones that we're reading in this direction. Then it gets back to normal 2, and then 3, and then 4, and then 5, and then 6, and then 7 just happens to be the same in both directions on the scale. But there's always going to be one where it's the same. But you're going to ignore every other number on here and just know that, okay, well, if this is 2, then that's 3, because that's 4. Halfway between 2 and 4 is 3, right? So you're just measuring from that direction over here. So the first number we find is 10. So we just talked about that. Okay. We just know we can read that as 1 foot over there. And the second one is 2, and that's correct for our scale, and then 4, and so on. So that's going to be what we're going to end up using. So this line, if we put it up against the scale ruler, is just like using our little schoolroom ruler. We're going to read that as how long is that in 1/2-inch scale. So we know this is 0, so that's 1, 2, 3, 4, and 5. Even though it says 8, that's the other scale going in the direction. That's going to be 5 feet long. Great. So, but what about this line? So it's longer than 5 feet, but it's not 6 feet. So that's where the little mini ruler on the end comes in. And that little mini ruler, you can think about that as a little scale model of a ruler. That would be the right size for your model. So if we jump in here, what we need to do in this case, if we're trying to measure a line in this scale, what we're going to do is take and slide that over so that we're going to take it down to the smallest round foot. So we know that it's 5 foot something. So we're going to slide it over back to the 5 foot mark, which in this case is marked with the 8 there, right? So we're sliding it over. We know it's 5 foot something. And now the extra bit, the hangover bit there, is on our little tiny dollhouse ruler over there. So we can look in there and say, the little mini ruler shows us how many inches are going on there. And it looks like it's taken us right to that 1/2-inch mark. Remember, it's reading in the other direction now, 3, 6, 9, 12, right? So we've got 5 foot 6 inches in this case, because it looks like it's hitting about the halfway mark there. So that's all that the little dollhouse ruler is doing. So if we were to make that line a little bit longer there, in this case, I'd be looking at that and saying, like, all right, well, that's 9, and then the next one is 10, 11, 12. Okay, so that looks like that's about 10 inches long. So 5 foot, 10 inches long. So not all of the little gradient markers are marked because it's just too small to see them all in there. So that's all you need to do in order to add inches on top of your whole numbers.
Nigel gave me a drawing that said 18 inches, all right?
I know he did, and that's what I'm talking
whether
about.
he knows the difference between feet and inches is not my problem. I do what I'm told.
But you're not as confused as him, are you? I mean, it's not your job to be as confused as Nigel is.
It's my...
So if any of that doesn't make any sense, just ask me about it. But again, all you need to do for the elements of design assignment is just use that ruler, that schoolroom ruler, your regular ruler that you've got lying around your house, and just kind of convert things by 4, right? So if a 1-inch line is going to be a 4 foot line on your drawing. So you're going to draw in 1/4 inch, and if that doesn't make sense, then just email me, ask me about it, and we'll talk.